So moving on to another practice problem, like you can remember in the nodal analysis, when dependent current sources they came into the problem, that made things a little different. So the same is the case for the mesh analysis. So I've just introduced a dependent source in this circuit, which is right here, and let's see how things would be now. So we'll just write the two mesh equations. These are the two meshes clearly. I1, I need to find an I2. So I'll just write the equations KVL on mesh 1, and let me just start off from this point, and I write -5 moving clockwise. I encounter this, so -4 ix, which is the parameter the dependent source is dependent on, which is right here. And then there's this 4 ohm resistor, an intersection between mesh 1 and mesh 2, and plus, and there's this 4 ohm resistor, so plus 4 I1 is equal to 0. And now let's write the mesh equation on the second mesh. So we'll just start off from this point. There is this 4 ohm resistor intersection between mesh 2 and mesh 1, and then there's 2 ohm resistor which is at the periphery, so plus 2i2, and then there's the positive terminal, so plus 3 is equal to 0. So these are the two equations I get from the mesh analysis. But there's this one problem here, and that is there are three unknowns, I1, I2 and Ix, and I've just got two equations, so this is unsolvable. So I'll just do what I was doing in the nodal analysis, and I'll write the parameter for the dependent source in terms of my mesh current, and that would bring my third equation. And if you do not get it, just look at the video for the nodal analysis, the practice problem for the nodal analysis, and you will know how we were doing it there. So Ix is this current, and I can clearly see that I have assumed I2 to be clockwise, so I2 is like going here and then coming here too. So clearly Ix is equal to I2, and I can just substitute it here for I2, and now I have two equations and two unknowns. So this is how you can easily solve problems with mesh analysis that include dependent voltage sources. Now Ix could also be in this direction, for example, and I would easily know that that means that Ix is equal to minus I2. Ix could also be going here, and I can clearly see that this is I2 minus I1. So in that case, Ix would be I2 minus I1. So whatever the current Ix is, you can just substitute the mesh currents there in terms of in which direction Ix is moving. So this is how you can easily form a third equation in mesh analysis whenever there are dependent sources. And I hope this makes things more clear.